our May meetup. So it's awesome to have you all here and joining us. We're going to start out with a little bit of music. So feel free to grab a drink, settle in, do whatever last minute stuff that you want to. And then in 15 minutes time, that's 7 o'clock London time, we're going to kick off. In the meantime, you can also come and hang out with other people in the meetup using Rambly, which you can go to at this URL, oishell.com/r. This is a little web app. You can go to it in your browser. You don't need to download anything. And you just get a little avatar that you can walk around and you can watch the meetup with other people and you can chat to people. So I'm going to be heading over there in just a minute. But in the meantime, welcome, and yeah, feel free to chill out for the next few minutes. Whoa, I think the music just died. Okay, well, in that case, since we're a couple minutes to go, I think we should just kick off early so that we can get straight into things. So once again, this is Cloud Native London. Thank you everybody for joining us across YouTube, on Twitch, and on Rambly. A little bit about us. We are a strong, open, diverse developer community dedicated to the cloud native platform and technologies in London. Been running for just under 3 years now. I believe June or July will be our 3-year anniversary. No, 4-year anniversary, I think. So pretty exciting. My name is Cheryl Hung. I'm the VP of Ecosystem at the CNCF, which is the home of Kubernetes, Prometheus, Envoy, and many, many, many other open source projects within this space. You can find me on Twitter at Cheryl. And tonight we've got 2 talks for you. Usually we do 3, but our third speaker had to pull out, so we're going to just do 2 talks this evening. The first talk is going to be on simplifying stateful serverless architectures from Konstantin. And then the second talk is going to be on how to automatically detect and deal with deprecated APIs from Stepan. And then we're going to wrap up at 8:15 UK time. But first of all, I want to hear a little bit about you. So this is our usual live polling section. Please grab your phone or laptop or tablet, whatever, and go to this URL or cheryl.com/p. And we're going to ask you a couple of questions about yourself, and then a couple of questions on how you use Cloud Native, just so we can all get to know each other a little bit more. So you don't need to download anything. It'll just be in the browser. You'll see this screen and you can either put in your name or you can just skip and go straight to the questions. So let's go in. And if you missed that link before, you can always use this slightly longer pollev.com link up here as well. Awesome, looks like people are figuring this out already. So you should have this question on your screen. Is this your first time at Cloud Native London? And you have 2 possible options here, yes and no. So just go to that URL and click on whichever one, yes or no. I think you can change your answer as well. That's why we saw a moment of like someone said yes and then they changed their mind. Oh, there you go. I think someone's coming in new for the first time, but it looks like we have a lot of returning people this time, which is awesome. Love to see people coming back. So I'll give people another kind of minute or so, just to maybe 30 seconds, just to figure out how to use Poll Everywhere and log in and submit their answer. So again, is this your first time at Cloud Native London? If it is, hit yes. If it isn't, hit no. Definitely the no's are winning out today. Another 5 seconds to figure this out. Hopefully you've kind of got a hold on how this works now. So awesome. But either way, whether you are coming back or whether this is your first time checking out Cloud Native London, super happy to have you here. Let's go to question number 2. So where are you right now? Obviously, this is Cloud Native London, but we are all virtual nowadays. So whereabouts are you? You should see a map of the world and you can just tap on the map and show us where you are. Looks like we've got some good UK representation across the whole UK here. I was going to question who was this person up here, because if you were joining from, I don't know, some northern parts of Canada, that's amazing. But I think that might have been a mistake. I think that might have been someone accidentally pressing that bit there. So awesome. This is always challenging for my sense of geography. I feel like I should study up on my geography before answering this question. Anyone know what this country is here? Well, if you know, you can tell me. But awesome, seems like we've got a couple of people outside of the UK, but mostly within the UK. Oh, Ukraine. Okay. I apologize. Then to the Ukrainians, I should have known. Awesome. Of course, we're wanting to get back to in-person events at some point, and people keep asking me, when are the in-person events going to come back? So London is opening up, the UK is opening up pretty soon. Hopefully we will be able to go back to in-person events in the next couple of months. Basically, we're dependent on when offices will be open again and we can use their space in the evening to host these meetups. So it's going to take a little while because businesses are still figuring out how to open up safely. But when that happens, I'm definitely keen to get back to face-to-face events. Let's go to our next question. What is your job title? So just pick whatever is closest to whatever your job title is right now. The options are architect, application developer, backend developer, engineering manager, SRE/DevOps engineer, security engineer, or anything else. And if it's anything else, then please feel free to comment and say what you're doing and what else, what it is you're interested in. So yeah, it looks like architect and SRE are pulling ahead. No application developers or backend developers joining us this time. That's a little bit surprising to me. Usually we have a couple here, but I think architects and SREs usually make up the bulk of people that we have joining, and a good representation of other as well. So as I said, if you are anything not listed on here, then please feel free to tell us what you're doing. And yeah, either way, very, very welcome and very, very glad that you are here. So thank you for telling us a little bit about yourself. Now I'm going to switch to the questions from our speakers tonight, and I'm going to ask Konstantin and Stepan to kind of comment on the results as they're coming in. And ooh, look at that, a late answer for application developer, just sneaking in there. Okay, let's go to a question from Konstantin. So what is the biggest challenge in developing and operating serverless/FaaS applications? So your choices are challenges related to security, orchestration, state and consistency, monitoring and performance, for example, cold starts, or testing. Or I think you can skip if you have no opinion on this. So yeah, now as we're watching the results come in, Konstantin, what were you expecting? What were you thinking?
Well, I haven't asked that particular question to an audience before, so I wasn't. I didn't have a particular expectation. The problems that stateful functions, what I'm going to talk about, solves are in here. They don't solve all of them, so so that is mostly about orchestration and state and consistency. So I'm happy that at least one or the other person clicked that. But of course, all of them are tricky. That's why I put them there. So I expected all to be clicked. Let's put it like that.
Yeah. Looks like a pretty even spread actually across all of these answers. Security just putting in there. And I know that you'll tell us a little bit more about state during the stateful challenges during your talk, which
that's pretty much all I'm going to talk about.
Yeah. Good to hear about. But do you have any other thoughts, or Stepan as well, like about any of these other challenges that you want to share before you go into that talk?
Nope.
Cool.
Not right now.
Okay, looks like the answers are, I was gonna say the answers have just settled. Security pulling ahead a little bit. But yeah, pretty even, I would say, across all of these answers. So nice. And let's go to Stepan's question. So the Kubernetes resources are internally stored in the API version that was used to create the resource, the the latest supported API version, the oldest supported API version, or another API version independent internal format? This feels like one of those more like quiz-like questions. So
Yeah,
what were you thinking when you asked this, Stepan?
I was kind of curious, but I was originally thinking that the questions will be asked after the talk. So I would love to see, how the results would differ after my talk to see if people took something away, because this is one of the things I hope I'll talk about, and I think it's useful.
Okay, so you actually answered this question as part of your talk.
Yes, if you'll pay attention, you'll know, you should know the answer to this. Hopefully it will change slightly.
So am I guessing that this latest supported API version may not be the correct one? Is that what you're suggesting?
Yeah, it may not be the correct one, but it's you're right. This is pretty very technical question. I would say kind of like internal stuff that you normally don't get so much to work with or see, or so it's one of the more difficult questions.
I think this is interesting to see anyway, just for people to think about it before they go into your talk, like what people thought about and what they'll learn as part of it. So it's pretty cool. Oh, I think maybe we shouldn't have said that, because I think some people might be changing their answers.
It's a moving landscape.
Yeah. Some people were switching to the API. Seems like the API version that was used to create the resource is pulling ahead.
And there are some good answers.
Being cagey, huh? Being a little bit. I guess we'll find out from your talk in a little bit. Yeah.
Hopefully, yeah. Hopefully.
Cool. Oh man, yeah. Okay. People really giving up on this.
I think we made everyone nervous right now. They're pulling back the question, the answers.
Yeah, people were desperate for documentation, being like, let's see if we can find the answer quickly. Awesome. Well, I really look forward to finding out the answer to this. And looks like a lot of people just don't know. So that's good. It means that people will come out of your talk at least learning the answer to this question. Awesome.
Yeah. I think that's at least for me why I joined the meetups. Usually it's one of the primary, apart from meeting people, that's one is always to learn stuff. So hopefully. Definitely.
Awesome. That is the end of our live polling section. So I want to thank everybody for joining in and for submitting their answers. And we are now going to move on and thank our sponsors tonight who keep this meetup running. So from Technovo, Lizzie, do you want to kick us off?
Yeah, of course. Hi, everyone. I'm Lizzie from Technovo. We're a challenger digital consultancy. We provide expert partnership and growth without creating dependencies or disrupting culture. We work on some really exciting transformation projects across both public and private sectors and pride ourselves on investing in talented developers working together to provide the best possible outcomes for our clients. If you want to know more or want to just chat, feel free to find me in Rambly or follow us on LinkedIn or Twitter.
Fantastic. Thank you so much. Let's go to Jai. Let's introduce UMatter.
Yeah, sure. So I'm Jay from UMatter, one of the founding team here. We're a technology recruitment company primarily focused in the cloud space. Our aim is really to put people back at the center of the recruitment process and remind every person we speak to really that you matter. So yeah, if you're hiring for your team right now, looking for a cloud position or just want to know more about what we do, then feel free to get in touch.
Fantastic. Thank you so much. I believe that Humio is not able to send a representative for us tonight, so I'm actually going to skip over them quickly and move to Zan.
Yeah, hello. Hi, everyone. I'm Zan Markin. I'm a developer advocate at Circle CI. We are the leading CI/CD platform. We're super flexible in what you can do. Essentially, we're letting DevOps teams of all sizes and everywhere in the world to build apps for any platform you can imagine, and as well as deploy it to any environment you can imagine. And we've always been great for building and testing apps and also deploying them. But yesterday, we also shared some exciting news. We announced a new round of funding and acquisition of the company called VAMP that helps automate the release process, which is pretty exciting. So if you're thinking about how software is deployed, deployed, and then also released to actual end users, there's a lot more exciting stuff to come, but if you want to hear more, you can go to circleci.com and read our announcements on our blog or also in many of the tech media. Thank you very much.
Nice. Congratulations on the funding. And Ashley, would you like to finish us off?
Yeah, super. Thanks very much, Cheryl. Yes, Palo Alto Networks, and I'm Ashley Ward. We sponsor this because we love things that are cloud native. We sponsor a number of these events because we secure cloud native platforms. We are a cloud native security platform, but more importantly, from my point of view, we're hiring. Please, please come along, come and get involved. We really want to hear from people who have experience in delivering cloud native technologies. Have a great meetup.
Fantastic. And once again, thank you to all of our sponsors for supporting us and keeping us going through this year of pandemic. So I really appreciate it. And if you want to come and join Cloud Native London as well, you'd like to come and speak or to sponsor the event, then please go to this URL, cloudnativelund.com. We have a handful of speaking slots coming up from July onwards. You can also sponsor us and promote your own events if you like to. And I'm going to stop at this point and hand over to Konstantin. Would you like to kick us off with your talk?
Yeah, thank you. Let me share my screen. I hope you can all see it. Yeah, thanks for staying for my talk, not leaving immediately after the poll or so. My name is Konstantin. I'm an Apache Flink committer and a product manager at Ververica. We are the company that was founded by the original creators of Apache Flink back in 2015 or so. We have by now been acquired by by Alibaba, so we're now a subsidiary of the Alibaba group. We mostly work on Apache Flink, as well as stateful functions, which I'm going to talk about today. But we of course also have a commercial platform called Ververica Platform. Basically bundles Apache Flink with more operational tooling into a more enterprise-ready platform. As I said, we're mostly working on Apache Flink, and what Apache Flink has become famous for in the stream processing big data space, so a little bit different space than the cloud native space is stateful stream processing, where you do things like windowing, real-time analytics, real-time aggregations, alerting, and so on. And over the last 2-3 years, we have kind of tried to take the experience that we have from building a world-class stream processor and started kind of expanding into other fields. And that was on the one hand streaming analytics, where it's all about SQL, streaming SQL, batch and stream unification, these topics. And then on the other hand, event-driven applications, more general purpose applications than just stream processing applications. And that's where stateful functions fits in, and that's what I'm going to talk about today. Even more specifically, I'm going to talk about stateful functions from a, let's say, serverless angle. So serverless, I think it's a quite overloaded term. So I'm basically going to characterize it by what people are usually looking for when they use a serverless product. So usually they look for rapid scalability, very fine-grained scalability on the basis of a function or some other unit, if we're not talking about functions as a service. We're looking for scale to zero downtime upgrades, or at least very fast upgrades to the application code. And we're generally looking for simpler operations, simpler development, very small development bundles. If we look at serverless architecturally, then usually this is a very that it's a tiered application. So, or maybe one step back. If we have a stateless application, I think all of these properties are more or less solved by the functions as a service services provided by the big cloud providers. Can also look at KNative, or even a simple deployment on Kubernetes provides a lot of these properties to a good extent. If we're looking at a stateful application, then a serverless application or function as a service application basically looks like a classical two-tiered architecture. You have some application code, some services, and you have some databases. And usually what happens there is a request comes in, the application goes to the database returns a value, then this application, well, in this case, it calls another application. This other application goes to its database, retrieves something, and well, goes back, returns this response to application 1, and application 1 finally returns some result to the client. So this all works pretty well as long as everything goes well. As soon as something goes wrong, for example, application 1 doesn't receive a response from application 2, things become a little bit more complicated because now application 1 basically needs to retry the request to application 2. And application 2, well, depending on where things have gone wrong, in this case, it was just the response that got lost. Application 2 needs to do different things. In this case, it had already updated its database, its state, so it probably shouldn't do anything. In the end, every application needs some retry logic. Every application needs to be able to deal with duplicates or duplicate requests, and things become quite complicated if you want to have exactly one's behavior across these applications, or consistent behavior across these applications in the presence of failure. Now, if we look at the same thing in say the serverless world, in this case AWS, could be anything, then maybe my requests are coming in through something like Kinesis streams. I'm from the stream processing world, so tend to streams. And a Lambda consumes these streams, calls other Lambdas. All these Lambdas store some state in RDS, but could also be DynamoDB. Doesn't really matter for this purpose here. And again, you have exactly the same issues. You need to work quite hard to get consistent results or consistent behavior between these functions. You need to think about retries and so on. In addition, you're also paying for wait time. Usually functions as a service are paid by time, as you might know. So while the first function is waiting on the other one, you pay. While you're waiting for your database to come back, you pay. So usually what you do is you put something in between, like a queue, so you don't need to wait for the other function to return, but you just put something in the queue. The other Lambda reads something from the queue, puts it back, and so on. Then you have mitigated that problem. The whole thing has gotten a little bit more complicated. You now have to have all these queues, but there are more challenges here. So the Lambdas pretty much scale indefinitely for like most or for practical purposes, probably much sooner your database or the connection to your database will actually become the scaling problem, because these services they're stateful, and scaling stateful services like a database is just much harder. So tricky. So now from the stream processing world, we thought about this challenge, and we thought, what if actually not the application is the boss and the application is calling the database? What if the database is actually calling the application? And that's kind of the main idea behind stateful functions. So in that case, the request would go to the database. The database would know that for this request, it needs to call application 1. Application 1 would return the response, and it would say, well, we also need to call application 2. So the database would call application 2. It would also get a response that would go back to application 1. And in the end, the database would return the final result. The nice thing about this is that now the database handles both the messaging and the state. So if the database notices that something has gone wrong, that some message got lost, that it didn't get a response from some application, then it can roll back state and messages consistently to the same point and basically redo the messages from that point. And one thing I forgot to mention here, when the database calls the application here, application 1, actually important detail, it calls this application with the request, the original request, and all the related state as part of the payload. So the applications itself here, they remain completely stateless. They basically get all the state and the request with the invocation. So again, back in the cloud picture here, yeah, we're basically looking for this database that does messaging and state together. And this is actually what Stateful Functions is doing, a Stateful Functions cluster. And it's also what a stream processor is basically doing. It's doing, or stateful stream processor is doing. It's doing messaging and state as one system. And Stateful Functions is built on Apache Flink and is exactly that system that provides this orchestration between functions. An important detail, Stateful Functions itself is the individual cluster nodes, if you will, or cluster processes. They don't require any local state. They are also stateless. So if you would deploy them on Kubernetes, it would just be a deployment and then maybe a job or 2 deployments, no persistent volumes or anything. The whole persistence of the state, the fault tolerance, is provided by S3 or any other blob storage, which is basically a commodity and very easy to manage for you as a user. So you don't have to deal with any of the kind of hard things when running a database on top of Kubernetes, for example. It's all stateless. Just give it an S3 bucket and that's it. Yeah. So if we look back at this, like why serverless or why stateful functions here? Basically, stateful functions keeps all the like nice properties that serverless or functions as a service gives you for the stateless tier, for your application tier. These processes remain, the functions remain stateless. You can scale them up and down. You can scale them to 0. It's basically all the same. Just what stateful functions additionally brings is consistent durable state for your functions. Cloud native fault tolerance, that's what I mean with S3 instead of persistent volumes. And simple messaging between the systems. There's no service discovery, and you get strong ordering guarantees between the messages that you send between your functions. So that was kind of the motivation. Let's look at how this actually looks like, or what it is in detail. So the building blocks of stateful functions are functions, individual pieces of code, pieces of logic that usually represent an entity. You can also think about it as an actor, a stateful actor, and they are invoked through messages. They message each other, and if a function is not active, if it's not invoked, then it doesn't consume any resources, doesn't consume, for example, memory or so. The functions can be implemented in any language that supports HTTP. Out of the box, we have Java and Python SDK, and there are also a couple of community SDKs, for example, in Go or Rust. The functions can message each other arbitrarily. This is maybe coming from the application space. This seems trivial. Coming from the stream processing space, or the data processing space, where you usually have a static DAG, a static graph. This is worth mentioning. So they can message each other arbitrarily. They just message each other by logical addresses. So you can message a function, a user function named Konstantin or Peter, just by sending a message to user Konstantin. No physical addresses or anything. And every function can have consistent or can have local state that is consistent exactly once. Messages go in and out through event ingresses and egresses. These are usually message queues like Kafka or Kinesis, but any other Apache Flink connector can also be used here. And we'll keep adding new ingresses and egresses. Message queues are kind of are a nice fit for stateful functions, because we rely for fault tolerance on the fact that you can rewind the messages from your ingress. So we need something that is replayable. The fault tolerance, as I said, works via state snapshots. No, there's no database required, just S3 or any other blob storage service that uses Apache Flink's basically distributed snapshot model that has proven to handle state in the terabytes in a single application. And yeah, it's just very hardened over time at very high scale. So before we look at some code, so that you have kind of a complete picture, how does stateful functions fit together with kind of Lambda, or how do you need to think about that? So usually Lambda, you have something like a request reply handler or a handler, be it in Python or in Java. And stateful functions also comes with a request reply handler class that you can basically dispatch messages to. So what you basically need to do to use stateful functions in Lambda is you need some kind of bridge that translates between the two interfaces, the handler, the request handler of Lambda, and the request handler or the request reply handler of stateful functions. I'm not going to show that code. It's maybe 150 lines or so, where I'm unwrapping some JSONs that I get from Lambda and so on. And I'm going to focus on the implementation of the individual functions, the individual stateful functions that are then which the request reply handler of stateful functions dispatches to. So let's see if I can switch to the code. Yeah, so I have a small application running here. this is kind of the architecture. It's very similar to basically what we've seen in the slides. We have a Kinesis stream with names coming in. This small JSON here. And this goes to, and the output that in the end we get is a greeting. And you already see that running down here because it's been running since this afternoon or so. So basically, hi, Konstantin, nice to see you for the 6,000th time. So it's basically a counter so that we have some state, and it's also going to tell me when I've seen it the last time. And the way this message is generated is by two functions. So the first, everything that comes in is routed to the user function, and then the user function calls the greeter function, and the greeter function finally sends the result to the Kinesis egress. And then that's what we are trailing here. So we can quickly look at the code so that you can get an idea of how that looks like. I said I'm not going to show.
You might have to make it a little bit bigger, Konstantin.
Yeah, we'll do. So I hope that makes it bigger. Yeah. So here we have the user function. That's the first function that gets everything that comes from Kinesis here. Implemented in Java, and it implements stateful functions, which basically means it needs to implement this apply method here. And the first thing that it will do is it will call this, or it will get an instance of this address scope storage. And that's something that, or the idea here is this is this stateful storage where you can put values and you can get values like your database, but it's always scoped to this address, and the address here is the person, the name. So I get the storage, and then I can get the last the current scene count. How many times have I seen this person? If there's not, if I haven't seen him or her before, then it's 0, and I increment that count. I do the same for the last time that I've seen this person. I update both values and build a user profile. A user profile consists of the name, the current scene count, and the time since it was last since the person was last seen. And then I send this message to another function, greeter. The greeter function, in turn, get out of here again. The greeter function is a Python function. So this also shows kind of the polyglot nature. We have a kind of cross language type system. So also this function can do something with the user profile, and it receives the user profile, takes the different values out of here. And this function is actually completely stateless because the only thing it's doing is it takes these values and it creates this nice message and sends it to the Kinesis egress. This is, of course, a little bit degenerated. You would normally not put this, like such a trivial logic, into two different functions, but I wanted two functions and I didn't want to make the logic more complicated. So that's how that happened. So all of this, as I said, is running on Kubernetes, or is running on Lambda, but the stateful functions cluster is running on Kubernetes. We can also quickly have a look at that. It's in that case three worker processes, one coordinator, and well, it's basically arbitrary. The load is minimal here. Could have also been one single process. Important thing, as I said, there are no PVCs or anything. The whole state and fault tolerance is handled via S3 here. Yeah. What else? I think that's all I wanted to show here in the code. Just wanted to give you an impression of how such a function looks like. And I'm happy to go back to the code later if there are questions in that direction. I think the questions you can submit via the polling tool as well. So back to the slides. Oh no, that was not back to the slides, I think. Yeah. So instead of Lambda, you could also that was the demo. And actually, important thing, if you're interested in the demo, check out this repository. It basically contains not only the functions code, but also the whole Terraform setup. Can basically bring up stateful functions, the Lambda, the gateway, everything to get basically this running example here if you have an AWS account. Yeah. So of course, this stateful functions is not tied to Lambda or functions as a service in general. You can also put basically you just need something that can serve HTTP and can serve these stateful functions. So that could be, for example, Micronaut if you or Spring Boot, or it could be Flask if you're using Python, or it could be anything. So we have, I think, in the community now, Haskell, Go, Rust, and there's also Scala SDK. And basically with the Java SDK, you can, in the end, use, I think, every JVM-based language as well. So if we're looking at stateful functions, not only for serverless, but also beyond that, then you can also use stateful functions to kind of get consistent state and messaging between any applications that run in completely heterogeneous environments. It could be a Java application deployed on premise and some Python functions that you have deployed on a Lambda because you need very rapid scalability for that. But everything else is a monolith in Java. Then that works. You still get kind of the consistency and the simplicity that you would have in a non-distributed environment in terms of state management, at least. Yeah, it could really combine anything. And another kind of final thought, also looking a little bit into the roadmap. If we think about these state snapshots, I said for fault tolerance, we're taking a snapshot of all the state and store that to S3, and we do that periodically, usually like every minute or so. But we're working a lot in the Apache Flink community right now to bring that down to seconds for most applications. So now we have these state snapshots, and these state snapshots basically are logical point in time snapshots of the state of all your applications, of all your Lambdas, for example. And all your Lambdas at that point in time have seen the same messages, and it's really consistent globally, like a kind of distributed heap dump, if you will. And we think it would be very interesting for introspection, for reasoning about your distributed system, about the state of your application, if we could make these state snapshots queryable, so that you can have maybe query them via SQL or some other way, to really get a consistent point in time snapshot of your whole distributed architecture. So that's one of the directions that we currently are looking in stateful functions. So if you found this interesting, I hope you did, then join the community. share your use cases and your ideas. We have a very active mailing list. It's basically the Apache Flink mailing list that also covers stateful functions. We have Flink Forward 2021 coming up in October, which will have for the first time a dedicated track for stateful functions. We also do regular meetups. Put some resources here, basically the documentation and things like that. If you have any questions, feel free also to reach out to me after the meetup. And yeah, I hope I hope you will. If you found it even more interesting, we're also hiring. We're hiring basically across the stack for stateful functions, but also all the other teams working on Apache Flink and Ververica platform. We're hiring product managers, solutions architects, technical writers. Yeah, you can reach out to me. You can apply directly on our website. And now I have, I think, 4 minutes for questions, if there are any.
Yeah, awesome. Thank you so much, Konstantin, for sharing and presenting and showing us this. I'm going to take over sharing the screen for a moment so that I can bring up another live polling screen. Again, if you have any questions for Konstantin, then you can go to this link on your phone or tablet or laptop and just type in your question. You will also get, this is like a Reddit style thing, so you can also upvote and downvote any questions that come in. So we'll just give it maybe, yeah, sort of 3 minutes or so to see if there are any questions that people want to ask. If not, then I will hand over to our second speaker, Stepan. But yeah, I mean, I come from a storage background, so I'm always interested in how you can do distributed state and how to get that consistency. And I'm interested, actually, I'd love to ask you a question myself, which is about the effects of running stateful serverless functions with, sorry, let me get this correct. What are the effects of latency on this?
Well, I think like coming from stream processing, the latency will certainly be higher for a stateful functions application compared to, let's say, an Apache Flink application, because in Apache Flink everything is running in the same JVM, same process. The functions are basically embedded in the runtime, so it's just function calls, right? There's no well, there's some network, but there's not a network for every call. So in Apache Flink, you can go down to the 2-digit millisecond latencies or so end to end. In stateful functions, I think the latency will in the end be dominated by the calls to the functions, to the individual functions, because every function call goes over the network, and if a function calls another function, it also goes over the network, and the end-to-end latency is then dominated by that. But I would argue that's probably the case for most two-tiered applications, where the request to the database or the request to another service that then needs to call its database is also a dominator or a significant factor, at least. Just that in our case, it's the other way around. In our case, the database, if you will, is the driver and calls the functions, whereas usually the function calls the database.
I think that makes sense to me. I mean, have you tried measuring the overhead? Like what? Just for
I know we have some benchmarks, but I think they're even part of the main repository. But I don't know the results exactly.
I might take a look afterwards and just, because as I said, I come from a storage background, so for me this is always interesting to know.
An important aspect, maybe if the question also comes from that direction, the snapshotting to S3. This is of course asynchronous, so that's not in the kind of the main path of the applications. That happens in the background and while processing continues. So you don't have the latency of storing anything to S3. Important side note. Yeah.
Okay, looks like we don't have any questions that are coming in. Maybe your presentation was just so fantastic you answered all the questions that people had already. But if
probably not. Yeah.
People can always get in touch with you afterwards, as you said, via Twitter and so on, right?
Thank you.
Awesome. Yeah, thank you very much. Really appreciate it. With that, I'm going to hand over. So Stepan, would you like to share your screen and take over?
Sure, thank you, Cheryl. Let's start. Let me share the screen first. Okay. Share.
Looks good.
Okay, perfect. When did the Zoom control panel disappear? There we go. All right. Cool. So you can see me, you can hear me. That's great. Perfect. So hello, everyone. Welcome. Thanks for joining us. It's a pleasure to be here. I'll be talking about Kubernetes API versioning and API deprecation, and also about the little tool kubent that we wrote to help with this. So this is a very brief agenda of the topics I'm going to touch. So a little bit of intro to Kubernetes API versioning and what do we actually mean when we talk about API deprecation. We'll talk about why should you care. I'll touch, that's related to the question, also like how Kubernetes handle API or object versioning internally. Then I'll show you how to check if this problem affects you. And then I'll introduce and talk a little bit about the kubent tool, which helps you how to detect this. And we'll close with how can you actually fix the problem if you're affected. Before we dive in, let me quickly introduce myself. So my name is Stepan. I work as a senior cloud architect for DoiT International. So what we do is we help our customers build basically scalable and secure platform and infrastructure in a cloud, design, manage, operate, control cost, etc. You can find me on Twitter. I usually tweet about Kubernetes and Google Cloud. Also occasionally write some blog posts. Cheryl mentioned anniversaries, and I was actually like earlier, we just talked about before the meetup a little bit, and I was just remembering like that. So I've been working with Kubernetes for quite a while, before it was even like 1.0, kind of before it became the big thing, I would say. And I was just remembering like that I was actually at the London 1.0 launch party. I think it was 2015, in-person meetup when that still was a thing. Yeah, I do contribute to some open source projects lately. It's this Kube No Trouble, which is a little project of mine. As you might have guessed, I do have a cat. She loves computers, although I suspect for a different reason. But yeah, my MacBook keyboard is her favorite place to hang out. With that, let's dive in. So let's start with a little intro to Kubernetes API versioning. So as Kubernetes evolve, so does the resources that we worked with, right? Because fields and structured resources, fields are getting added or deleted or just changed, so there is a need for versioning. Resources in Kubernetes are divided into groups, and the versioning is for the groups as a whole, right? So when you're working with a manifest with some resources like on the slide, you'll see there is a field called API version, which basically reflects or where you specify the API version that you're going to use. Now, this directly translates to the URL, which your client, typically it's kubectl, but any client that works with the Kubernetes API has to call a specific version. So this directly translates to the URL. You can see it at the bottom. It would be something like API slash, that will be the API group and the version of that group, right? One thing to mention here, that the versioning is explicit. So in a sense that you as a client are responsible for calling the version, the specific version of the API, right? There's no guessing. The server will not try to guess what you meant. You as a client have to call the correct version. That's pretty much it. Now, if we talk about API deprecation, what it actually is. So as new versions of APIs or groups of APIs are being introduced, the old ones are deprecated and eventually removed, right? Because typically this is because they are replaced with the new versions as they evolve. There are cases when they're just removed, but the typical life cycle is that first the new version of the API group is introduced. Then the old one is announced as deprecated, and they will kind of be present for a while. And finally, the deprecated one is removed. That means that the API server will stop serving it, that you can't use it anymore. This is governed by a document called Kubernetes deprecation policy. It's pretty complex. So it says kind of when you have to increment API versions, if you change resources, for example, when you remove a field. It also says how long has given APIs, how long you have to support given APIs. For example, once the API is like in general availability, they have a policy that it has to be supported for at least 12 months. And it's pretty complex, so there's more rules. I took one example for this, which we'll further expand on, and this is example of ingress. So if you work with ingress resources, you might, it was currently or originally, you would still work with extensions v1 beta 1, and then it was moved to networking v1 beta 1, and both of these versions have been announced now or are marked as deprecated, and they will be removed in 1.22. But currently, if you work with something like, let's say 1.19, you can use still the old ones and the new ones. So to sum up, the API deprecation is a problem when the old version of resources or the API is being removed. This is when and it would cause you troubles when you upgrade your Kubernetes version, when you upgrade the cluster. I put in some examples. This typically doesn't happen in every version, but like kind of, let's say, big first removal was in 1.16. That's when it surprised a lot of people. And you can see all these versions of kind of core APIs like daemon sets, deployment, stateful sets, they're removed. And so if you didn't migrate to the new versions, you were kind of in a trouble. So that was in 1.16. The next kind of planned removals is in 1.22. Does remove a lot of, or affect a lot of resources, including resources like ingress that I already mentioned, or RBAC resources, roles, role bindings. And then 1.25, there's another set of like the API groups that will be changed. I highlighted here the pod security policy one. It's because that's an example of one that's not being replaced by a new version, but that's being removed. So if you use pod security policies, you might think about what you're going to do in the future, because currently there is no replacement. But it's a little bit out of scope for us. So why should you care about this, right? So as I said, this problem, this would cause you problems when you upgrade a cluster to new version, right? So obviously, if the API version was removed and you will still try to use it, it will not work. You'll get an error back. The same thing is as part of the migration to the new versions, the APIs and the resources change structure, right? So if you would only change the version of the API in your resource, but you wouldn't change the structure. If it did change, this is not always the case, but if it did change and you didn't restructure your resource accordingly, again, it would fail. Another kind of problem to be aware of is that also defaults value sometimes change. I'll give you little bit more specific example of all these failures that I've seen. So I often work with clients, and this was one of kind of big problem for a lot of people, that they were not aware of this, and we've seen a lot of failures after they upgrade their clusters. One thing to note, I would say this doesn't affect only core resources or the resources that you get by default with Kubernetes, but the same principles apply to custom resources, right? So if you use some applications that extend Kubernetes API by CRDs or aggregated APIs, but introduce custom resources, you will have the same problem. So to show some specific examples, right? So one is obvious, that's kind of, it can break your CI/CD pipelines, depending how robust it is. You'll try to use a resource that was removed or deploy a resource that was removed, it will fail. If your pipelines are not robust enough or you don't do enough testing, it might even break your services. Something that's a little bit more, a little bit less, I would say, obvious, sometimes more difficult to catch, is that this also affects any applications that talk to the Kubernetes API or any third-party applications you might have deployed or controllers, right? So one example of failure I've seen was that there was an application that was responsible for managing and renewing certificates on the services that were exposed. And, you know, in this case, the team updated their Kubernetes cluster and everything looked okay, right? Everything was still working. So they moved the same upgrades to production. It all looked good. But at some point, they had downtime caused by broken certificates. And this was because the application that was responsible for renewing the certificates actually, like the resources that it was using changed and the application wasn't ready. So the renewal of the certificates was failing. They didn't catch it in the staging because typically, you know, the staging environments are a little bit shorter lived. So you have a bigger chance to hit this in production. So yeah, that was one example, and it wasn't quite obvious. Last example I wanted to mention was about the change defaults. So it was another case when the team worked with a distributed database, and this was related to the changes in a stateful set. So the default update policy in this case for stateful set used to be on delete, which meant that even if you updated the stateful set, you had to delete the pods and for the changes to take effect, right? The changes would take effect only after the pod would get recreated. So these guys had some little bit more, you know, it's a distributed database. So there was some more sophisticated mechanisms, how you upgrade nodes. You would have to first take them out, make sure that there is no traffic going on, do some rebalancing and stuff. Then you would restart the pod to get the new version and then do some checks and bring the database node back in. Because the default update policy changed to rolling update, which they were not aware of, suddenly when they did the next change that they were used to, the Kubernetes started restarting the pods one by one immediately, right? Without all the orchestration around. Guess what? Was another kind of downtime that it caused them. So yeah, you should care because it can break your application and pipelines and stuff. Before I will go a little bit deeper into, or before I will show you how to find out if you're effective, let's look at, I want to stop at looking at how Kubernetes handle versioning internally. So this is a quick overview. So if you create a manifest and you send it to Kubernetes API using kubectl or any client, as we said, the version will be reflected in the URL, right? Kubernetes will receive this and deserialize this to internal versioned objects. So in case of our ingress, if you use v1 beta 1, it will be converted into internal v1 beta 1 versioned object. But that's not where we stop. So the next step, there are defaults applied, and there is actually like more going on obviously, but I picked the steps that are relevant to us or to the scenario of API versioning or resource versioning. So the next step, then it will be converted from this versioned type to internal type, which is not versioned. right? There is like only one version of this internal type, and that's how the server works with the resources internally. And there's another conversion which will happen when the resource is going to be stored. So when the resource will be stored, it's stored again in a version format. So in this, and this version format is though different to the one that was used to, or can be different to the one that was used to submitted via the API. So it will typically be the latest supported version, right? So in this case, it would be stored in the version 1 ingress, and Kubernetes use etcd as the backend. If we look at how this works when you query resources, it works exactly the same way, just reverse. Again, the version resource is read from etcd. It will be converted to internal non-version format and then converted again to the version format, depending on which version of the API you use to query. So there's kind of like double conversion happening there. And I'll talk about all these things. It might be a little bit abstract, so I'll quickly show you how this actually works. Okay, so I do have a Kubernetes cluster here. I picked 1.19 is my server version because I want to show you some of those things I talked about. And let's have a look. So what happens if you, this is surely familiar Kubernetes or kubectl get. Let's get this ingress, and I'll use a nice switch. If you might not be, it's handy if you want to see what's actually going on behind the scenes. You can increase the logging level. So if I do kubectl get ingress and increase the logging level with the -v flag, I'll see what is the, okay. Let's run it one more time. I will explain this a little bit later, what happened here. But if I run it, you'll see that the request was actually translated, and I can see the API call, right? This is what I've talked about. So it's translated to the call against the API, and you can see that the version is automatically added to this request. There is a networking group, API group, and the version is v1 here. So it's the kubectl client that edits this version. So you might be wondering how it figured out the version. There is a discovery mechanism that the client uses. So that's what actually happened here. You could see that if you don't use it for a time, I think by default it's 10 minutes, the client will refresh the information. But if you use kubectl, there is actually a cache. Basically, it's typically in .kube directory in your home directory /cache. There's discovery. It will be okay. It will be the name. It's by the name of your, or the address of your API. So every server has like you can see every server has a directory there, and that's basically what the Kubernetes client does. The first time you talk to the server, it will go through all these endpoints, and it will get information about all the endpoints available. You can actually do it yourself if you're interested how this looks like. There's another useful flag for kubectl command is you can use --raw. You can directly specify the endpoint you want to query. So if you query just the root endpoint of the API, like this, you'll get a list of all the available endpoints, right? And if we pick one, for example, let's pick the one we talked about, the networking ket-sio/v1, you can further query it, or let's do this. You can further query the general API group without the version. And this looks a little bit ugly. Let's make it nicer. What you will get back is all the versions that the API server support, right? So you can see that I have version 1 here. I have version 1 beta 1. It will also tell me what's the preferred version. This will typically be the latest stable version. If I want to query it a little bit further, you can pick one of those versions, and it will get me back all the resources. So you can see network policies in this group. There is the ingress that we are working with. It will get me all the resources that are available for this API group and version. So that's how the discovery bit works. Okay, now let's see how the conversion that I talked about works. So what I have here very simple ingress manifest. This is probably, you must have seen it many times. So it's just the ingress specification, and you can see that it starts with the API version, right? And I'm using the extension v1 beta 1, which is the deprecated one, but still available in this version. So I'll now apply this. KA is, by the way, shortcut for Kubernetes apply in my setup, just in case you would be wondering. And let's do this also, just to see what the client is actually doing. So you could see, right? Yeah, you could see that it's calling the API, and because in my manifest I use the extensions v1 beta 1 version, that's what the client is calling, right? It's calling API extensions v1 beta 1. And then there is the rest of the address, which is like a namespace and ingresses. Now, what is more interesting, what if I ask for this resource that I have just created, and I will say kubectl get ingress. The interesting bit is that even though I created it in the extension beta 1 version, what I get back is the networking version. You can see it here. Why is that? Right? It's because I asked, or the Kubernetes kubectl client asked for this version, for the default version, because I didn't specify it, right? You can, when you use kubectl client, you can ask for a specific version if you want to, but just to show you, but this is not typically what you do. What I can say this. If I would say I want beta 1 extensions, the client will ask for extension for this old version, and I will get it in the old version, right? So the Kubernetes server basically responds with the version that you asked for. I think that's pretty much it, what I wanted to show you. Oh, there's one more thing. So I wanted to show you that it's not just the version that's different. So let's get back the ingress in the new version. Let's save it. So I'm just saving it here. I'm gonna run a diff against the old version that I already had saved, and again this new version, which is the same resource, right? Just auto converted by the server because I applied it and got it back. And you can see the differences. So there's a couple of differences. So there is obviously the difference in the API version. That's what we showed and what we expected. There's some metadata that's also expected because the one is the version that's like live from the cluster. But what is more interesting is this. You can also see that in case of this ingress, when the ingress moved to the networking group version 1, it's changed structure of some fields, right? So it's changed backend to default backend. You can also see that the structure of service name and port changed a little bit. And so that's one thing you need to keep in mind when you're upgrading to a new versions. You might also need to do these changes if the format or the structure of the resource is changed. Otherwise, obviously, you would fail. Let's quickly show you that as well. So what would happen? So if you try to create a version, I have a deployment here in version v1 beta 1. And because I'm using server 1.19, this version has been deprecated, so it's not available. So if you try to create it, you'll get back an error, right? The server will tell me, okay, this version is not available. I don't know anything about that. That's because the API has been deprecated and removed. And I think that's it for this demo, and we can move on to the next part. Okay, how am I with time? All right. So how can you check if you're affected, right? So you're in a situation where you're planning to upgrade to a new version of Kubernetes and you want to know, will something break? And my question is, what's the catch? And you might have guessed that the problem is that because the Kubernetes are doing this double conversion of resources, basically the information the information about what version was used, what API version was used to create the resource is lost, right? It's not saved anywhere because the resource is converted to the internal state that's non-versioned and eventually to a version storage state and vice versa, but that information is lost, right? So it depends kind of, your options will depend on what situation are you. If you have the source manifest of your resources, that's easy, right? You can just check those. That's a good place to be. If you use some third-party applications that talk to your APIs, that's a little bit more difficult to check for. There are some new features introduced in 1.19. I'll talk about those that can help you. And finally, there is a situation which is pretty common in larger environments when you have a team that are kind of administrators, let's say, or SRE engineers that operate the cluster. And then you have different teams that deploy applications into the cluster. So you're in a situation where you don't have those the source manifests available, right, to easily check for those because they might be scattered across multiple different CI/CD pipelines and systems, whatnot. So that's more difficult to check for, and that's let's look at what the options are. So one of the options how you can check how the resources were created in a live cluster is audit logs. If you have those enabled, you can look there because you would see what versions are used to access the APIs. This is kind of, let's say, labor intensive. You might have to go quite a way back. You would have to parse those logs and everything, but it's an option. Now, since 1.19, there's been some improvements created. One of those is warnings, but that will only help you. Actually, I didn't mention it, but I think we have seen it when I did. Let me show you quickly. When you try to apply version that has been marked as deprecated, kubectl client will now give you this warning, right? That it tells you actually that this version has been deprecated and it will be unavailable in a future version of Kubernetes. So it's kind of trying to help you to remove this problem. So that is definitely useful improvement in 1.19, but again, it's only kind of helpful if you're applying the resources, or if you're applying the resources, right? Not once the resources have been applied or once the manifests have been applied. Now, there's another improvement which can also help you. That is, in 1.19, there has been new metrics introduced. So if you can query the /metrics endpoint, that's a little bit small. I hope you can still read it. If you query the /metrics endpoint of the API server, which exposes metrics in Prometheus format, you'll get back API server requested deprecated APIs metric with some labels. The labels describe the group and the resource. And this can have two values. Basically, it's either 0 or 1. And if you see 1, it means that this API has been called. It's not really like a counter, how many times it has been called. It's kind of like a binary. So you can only tell, has someone used this old API? Do I need to find out who it was and fix it before I upgrade my cluster or not? So it's somewhat useful. It doesn't really tell you who the caller was. And finally, this brings me to Kubernetes, which is exactly a tool we put together to address this problem when you're, if you want to find out if you're affected. So Kubernetes, it's open source tool. You can go to GitHub. It's published under DoiT organization. It's a short, Kubernetes is a shortcut for kubeno travel, which, as the kind of name suggests, is to help you avoid troubles. And the the main idea is that it allows you to easily check if your cluster uses, or if resources in your cluster were created using the deprecated APIs, and if it can cause you troubles when you're planning to upgrade. Before I give you a quick demo of how it works, let me talk a little bit about the motivation behind this. So, you know, when I talk to clients, and one of the things I would always, when we talk about, you know, designing and building infrastructure and architecture, one advice I would always give you is design for upgrade, right? So design your infrastructure in a way that you can continuously upgrade things, because tech and Kubernetes being a very good example of those move rapidly, right? So you need to kind of upgrade to new versions. If you don't do that, it's more difficult in the future, and things are more likely to break. So that's the theory, right? But the practice, unfortunately, is often that, you know, you deploy something as there, and unless you are forced to, no one will touch it, no one will upgrade it. So you end up with possibly old versions of clusters. But typically, like, the time when you have to upgrade will come. This can be because there is a security issue. This can be because you want to use a new feature that's only available in the new version. Or because you're using managed Kubernetes and your provider will force you to upgrade, right? And this was the case in which kind of motivated to create this tool, because we had a lot of customers. I worked mostly with Google Cloud, and Google Cloud, basically when they were forcing upgrades from 1.16, they would send this notice. So it will say something like, you know, you're running 1.15 clusters, we will upgrade it to 1.16. By the way, it might break stuff, right? And this kind of freaked some people out, because, you know, it sounds like you need to care about something. It sounds like your services might break. So this was the motivation behind this. And it was kind of like, original was supposed to be like, you know, one-time thing for 1.16. Then we got some feedback. People actually started using it. So kind of continue to improve it. So let me show you how it works. It's really quick. It's really easy to use. So typically, first you would have to, if you want to start using it, you have to install it, right? So you can go to the GitHub page. And one way, you can go to releases and download the binary for your architecture. We publish Linux, Mac, and Windows binaries. That's what I would recommend doing. If you really trust us, this is questionable practice from security point of view, obviously, but, you know, we're a good guy, so you can trust us. And I trust myself, so I can do it. There is for convenience, you can also just run this script. So let me switch here. And if I just run this script, it will basically download the latest release of the kubent tool, and it will put it into user local bin for you. So once you do that, you should be all ready to go. And without any further configuration, you can just run kubent, right? So let's do that. So you'll see some info messages, but what you should see happening is you'll see that it detected that I have a couple of resources that has been marked as deprecated in my cluster. That's a couple of ingress resources in this case, and that I should do something about it, right? We also tell you, like, obviously name and namespace of those resources, and the problematic version of the API that you use to create those, and what you should use to replace those with. This is like kind of out of the box. The tool picks kubectl configuration, so it will automatically try to, you know, connect to the cluster that you have configured with kubectl, and that's all that you need to do. There is some useful, you know, there are some additional switches and flags that you can use, because some people started it using as part of their CD pipelines. They just put it there as additional check. So you can, for example, ask it to output JSON, right? It's the same thing, just in JSON format. You can also, I can also tell it to scan from files. So I can tell it to, you know, scan some deployment manifest if you want to. So you can see that it still detected the resources in the cluster, but it also picked up the resource from the file that was the deployment that I showed you that you can't even create with the 1.19 cluster. So there are some additional switches, but the whole idea of the tool, it's super simple to use. You just run it out of the box. It should give you helpful advice about possible problems in your cluster. So I think this brings me almost towards the end. Oh yeah. So how do we do it? I told you that it's difficult to detect the version, how the resource was created, because this information is lost, right? So we use a couple of tricks, actually. We have concept of what we call collectors. So collectors is like the different sources of the information, right? So I showed you, you can also use files. Obviously, in that case, it's easy. But the kind of what I would say is the benefit of this tool, what differentiates it, is that you can run it against a live cluster. That's what I've shown you. So how do we do it there? There's a couple of scenarios. So one is if you used kubectl to deploy your resources. kubectl has this special kind of property that it will create this annotation on your resource, which is kubectl Kubernetes IO/last applied configuration. And this annotation actually contains the original manifest that you used to create the resource. I can quickly show you if I do this get ingress. So this is the ingress I created, and you see that one thing that kubectl did extra that wasn't in my original manifest was this annotation, right? So you could see the kubectl last applied configuration, and it contains the original version. So what we do, we parse this, and then we use that to detect the original version and warn you that you used old version to create your resource. Another popular use case is that people use Helm as a deployment tool. And Helm, when you use Helm, what Helm does is Helm basically renders the manifests and then stores the rendered version of the manifests in your cluster, either as a config maps or as a secrets, depending on how you have configured it, right? So again, what we do, we would parse those Helm manifests, and we would use those to detect the version of the API and eventually warn you that you used old API versions, and you will have a problem when you upgrade your cluster. And that's it. And finally, you might ask me, okay, so I have detected that I have this old APIs. I'm using these old APIs. I'm planning to upgrade your cluster. What should I do? How should I convert it to the new version? So I would say like the simplest, or what I would recommend you, the simple way is just apply those resources and then get them from the cluster in the new version. That's what would happen by default if you use cluster that supports, like in my case that I showed you, that supports both the old and the new version. That's one way, because just changing the API version in your manifest is not enough, right? If the structure changed, you cannot just change the API version, because then you didn't change the structure of resources and it would fail. There's also a kubectl subcommand, or was kubectl subcommand, kubectl convert. This has now been, or since 1.21, this has been moved to a separate binary kubectl convert, which allows you to convert your resources. The mileage with that might vary a bit, because you just call it like kubectl convert and give it the file you want to look at. And it would work, for example, for the deployments. It doesn't really work, for example, for the ingress. And I think that's because the ingress has been migrated kind of to not only the version change, but also the API group change from the extensions to the networking. So you would have to specify also the format, how you want to get your resource. So yeah, the mileage may vary, but it's the tool you can use. What I would really recommend you to look at this address, which is part of Kubernetes documentation, and it's called API Deprecation Migration Guide. If you open that, it's pretty good now. If you open that, okay, there we go. It basically contains list of all the APIs or API groups and their versions, and this is like divided by when these will be removed. Right, so you can see Kubernetes 1.25. These resources have some changes. Right, you can go to, there's 1.22, 1.16. So it describes the resources. if they have been migrated to new APIs. It also describes if there have been any changes you should be aware of. So if fields have been removed, if fields have different structure, or for example, if any defaults change. So this is kind of like the safest way, if you use these resources in old API versions, go here, check out what is actually changing, understand it, and adjust your resources accordingly. And that's it. So quick recap. We talked about how Kubernetes version APIs and resources, and what is API deprecation. That's a problem that you can that can cause you issues when you upgrade to a new versions of a cluster. We talked a little bit about how Kubernetes handle API and resource versioning internally. The takeaway point is basically that the resource that you use to submit, the API version that you use to talk to is different to internal version, and it's again different to version how it's stored. And basically the information about the original version is typically lost. I've showed you the little tool we wrote called kubent. So kubent can help you with this. You can just run it against your cluster and will show you resources which might be problematic. And I discussed briefly how you can upgrade those. I'll share the slides after the meetup. So I just put together links to the resources I've discussed. You don't have to make notes or anything. We'll share those slides. And that is it from me. So thank you very much for joining us. I would also like to use this opportunity to thank anyone who uses the tool. We have a couple of contributors, some feedback on the GitHub, some PRs, opened issues. So thanks, that helps us to move forward. If you like it, please share it, star it on a GitHub. Again, it helps. Kind of, as I said, this originally was a one-time thing just for 1.16, but because kind of got some positive feedback, that's why we continue to add new features and improve it. So also gives us some hint, like, what maybe I can prioritize, what people would be interested in. And I would also like to say thanks to the company I work for allowing me time to work on this, and my colleagues, especially David, who contributed quite a few things to this tool. So yeah, that's it. Thanks again. And if we have time for Q&A, I know I was a little bit long, but I'm happy to answer any questions.
Thank you so much, Stepan. That was a fantastic talk. I feel like I really learned a lot. We are over time, as you said, so I think the best way for people to follow up, I guess, is to use your Twitter.
Yeah, totally. Please reach out on Twitter. Yeah, I will hang out in the Rambly as well. I'm always happy to talk about Kubernetes.
Perfect. Thank you so much. Can I ask you to stop sharing your screen for a second?
Yes, sorry about that. Here we go.
Perfect. So that is it from Cloud Native London tonight. Thank you so much to everybody who joined us across YouTube and Rambly and Twitch. Thank you so much to our speakers tonight, to Konstantin and Stepan, for sharing everything that you know with our community. So really appreciate it. And as always, we will be back again on the first Wednesday of June, first Wednesday evening. So I look forward to seeing you all then. Take care and have a great night.
Thank you.